Hello, how are you guys? I am very happy to be here in Italy. I love Italy. So I'm Tara Walker. I'm a senior technical evangelist, and today we're going to talk about improvement in your productivity, hopefully by using continuous delivery and continuous integration. Now, I am excited that at the end of my talk, when I stop running my mouth, I'm going to have someone from Docebo. He's going to join us to talk about how he's actually used AWS and continuous integration and delivery in their own products and how it's increased their productivity. All right, so without fail, let's get started. Wait, really quickly, so if you have any questions after my talk, feel free to tweet at me. I actually answer things on Twitter and things of that nature. All right. So you guys probably have gone through the day if you've remained in this session, and they've talked about all the great things about serverless, how we do DevOps at Amazon, how you can use containers. So they kind of gone through the great meat of what we have there as far as how you guys can get started in using AWS for a production level environment. Now, how do you put all of those things together? So you now have the fundamentals, but how do you put all those things together to make sure that not only are you using some of the great services we've talked about throughout the day, but to make you more productive? So the first thing you need to think about is what DevOps consists of. It is not just the tools, and we've talked about that. It is also the culture that you put in place as well as best practices. And so I want to talk about some of those best practices that we do at Amazon that has enabled us to provide services to you and Amazon.com and keep integrating, keep innovating those great things. So the first thing I want to talk about is why does it matter to us? And it really matters to us at scale because we can't afford those failures. You guys talk to us a lot about making sure you have the best experience, not only when you're using our products, but quite frankly, we eat our own dog food. And over in the Amazon.com side, they really have very little reason or very little tolerance for failure. So we need to have a failure rate that is very low. And anytime we change things, that failure rate really needs to be low. So what else do we need to have that's really essential that you guys need to have? You need to really go from commit, so the minute you push your code, push your new environment, to production, you need to really make sure that's faster. And then finally, if you want to innovate, especially at scale, the faster you can get to market, the better it's going to be for your company, for your customers. And then what you want to do, hopefully, if you guys are doing this right and thinking about how you integrate, is that most of your time, and we have a number here as you guys see on the screen that's 44%, but hopefully most of your time is now spent, what can I do to add more features, more innovation, the new that can drive the productivity of not only my company, but to make your customers more happy. And so we have a number here of 44%, but that can go up and up as long as you're able to innovate and maintain what you have and grow that at a quick rate. So DevOps matters to enable these things. Now, what we realized as far as at Amazon, that we realized a lot of the times when we were trying to do this initially, that we spent a lot of time waiting. So we write code and we wait. Then we build our code, then we wait. And then we deploy and test, which imagine we have a bunch of stuff to deploy and test along the lines of a lot of things, then we would have to wait. And finally, after that, okay, we built the code, okay, we wrote the code, okay, we tested the code, we finally got to deploy this to production. That takes a long time and a lot of unproductive cycles if you're just waiting and spinning and waiting to make sure things are right. So what we found was this went from minutes to days to minutes to days of the waiting. That's wasted time. That's not being productive. That's not giving us those extra cycles to do that new innovation and those new features. And so what we want to realize is those little time and those days, those minutes, they actually add up to be weeks. That's totally not acceptable. We really needed to make sure this came down to a matter of hours. So taking out of that wait, deploy, write, code, wait, and that cycle, to get out of that and to really deploy it hours, we realized that we had to do something different. And this is where our DevOps and our system that you've probably heard about, our two-piece teams, and the things of that nature came into play. So by 2014, we realized by adopting things like microservices, actually putting things in place for a cool and great and integrated CI/CD pipeline, we could actually get down to hours in how we did our deployments. And that's whether that be on the Amazon.com side or the great services we provide to you as AWS. Now, continuous delivery doesn't have to be hard. And that's what we found as we were building these things internally to Amazon. This shouldn't be really a hard thing that people need to do. And if we can get this down to hours at the massive scale, we can enable our customers to do it as well. And we have a ton of environments. So it's not just one staging, one beta, one production. Imagine that being on steroids, where you have several staging environments, several beta environments, several production environments. I mean, look at that number, that's massive, 50 million deployments. And so we realized from that scale that we can not only get our time down to hours, but we can absolutely make it easier for you guys. So we have 5 major phases that you guys should think about when you're trying to release code, when you're trying to build deployment environments. There are 5 major phases that are really important for you to consider and what we try to enable. The first phase is source. Right? You got to build something. You have to write some code. You need to get that in. You need to make sure your code is hopefully of quality. So hopefully once you check that in, you're doing peer reviews. You're really examining the quality of what you're putting out there in your code. The second thing that happens typically in a major release phase is that you have to build what you have. You have to bring all those pieces together, all the parts of you built this part, they built this part, they're expert in another part, and sometimes that could be different languages. So you need to bring that all together for a build. And so when you do that, hopefully you're doing things like regression testing, unit testing. You have code metrics. How performant is your code? And these are key things that you want to make seamless as you start to build in an environment. So your build phase is very important. It's not just, oh, I built some code. Yes, it compiled and everything compiled together. You want to make sure that not only is it compiling together, but you're doing tests to make sure it's playing nicely and it's performant. Now, what is really important about this is you need to also understand what environment, what are the images that you need to produce to make sure your build, while it's working in build, we've all heard this, well, it worked on my machine, you don't want that to happen. So this is where you create your container images if you're doing things around containers. If you're serverless, this is when you make sure you have the right environments to build in for your serverless environments. This is where you create your images. You don't wait till it gets to production and go, but it worked on my machine. So this was another major phase we realized was important. Then we want to test. And okay, yes, you said you tested a unit. That was just the code. You want to see how your tests work out in the wild, or the pretend wild, if you will. But also, what if your code integrates with different systems? At AWS and Amazon, that's really key. We have a lot of things that integrate together. And you'll see this when I do my demo, that there are a lot of services that I'm going to use that integrate together. You want that experience to not only be seamless as you guys are building your code, but it was important for us that as a seamless environment as well. And so at the test phase, one of your key phases, you want to do even more load testing and performance testing. You want to do your UI test here. And again, these things should not be rocket science. You want to make these things very easy and very seamless. There we go. Now here comes the great part. You have done your testing, you've made sure it was secure, and now you want to deploy to production. You are ready to go. But it doesn't end at the deployment phase. Hopefully, I'm going to cross my fingers, you guys are doing some good things around monitoring your code in production. So hopefully, if something goes wrong, you guys know it before you get that call on the phone and the customer is saying, hey, this isn't working. Or I try to use your website, but it's just not going well for me. You want to be able to monitor errors that are coming up. Or, God forbid, something is being overloaded on in your environment and you didn't do a good job of scaling it out. You want to know that prior to a customer calling you or your systems calling, your internal calling and say something is wrong. So hopefully what you're doing is you're monitoring your environment. Now, let's be frank. For you guys to put this all together could be a little bit problematic. But like I said, we really learned from our 50 million deployments how to do this, and we wanted to share this with you. So all the things you saw that we talked about before, right, come together in what we call continuous integration, so that goes through source to build. And then you have your continuous delivery. So these things are staged on top of each other. First, we have continuous integration. This is where you're doing the source to build. That integrative environment where you're going over and over trying to make things right. That's where your continuous integration comes in. But then continuous delivery is, I've deployed, I want to enhance this, and then test and deploy again. And then finally, you want this to be a continuous deployment where every time you have a new environment, I've tested, I know my new features, I can do things seamlessly out there. So if you think about CI and CD, continuous integration, continuous delivery, helping you to have this entire environment called continuous deployment. So let's talk about some best practices. Your first best practice, and I kind of mentioned it briefly, but I want to really get into some practices that you guys should think about. Now, everyone hears microservices, and it's the new buzzword, so I'm going to say something that's probably a little shocking for you to hear. Everything does not work as a microservice. However, whenever possible, you want to get away from building monolithic type of environments, types of applications. You really want to make sure that you are in a microservice environment, because when things are broken down in these pieces, when one thing goes wrong, it doesn't stop your system from crashing and burning. So whenever possible, and sometimes that's not possible. Let's be clear, there are some systems that are so tightly integrated, or that you have gotten it humming in such a way that migrating this to a microservice is not feasible. It's not something you should do. But whenever possible, you should really get away from the monolith. Another best practice that you should really think about, and hopefully that we are enabling for you, and if not, we want to hear from you, is that you can use your infrastructure as code. So I don't know if you can see my screen really well, but I can literally model my entire infrastructure using a CloudFormation template. Or if you're into serverless like I am, I can model my entire environment using AWS SAM, Serverless Application Model. And what's great about both of those things is I can test that locally to make sure my infrastructure will be as it's planned. So not only can I have my code that I'm actually building my applications and my systems on to be ready to go and applicable to my environment, but I can make sure the actual code, the containers that's being run, are actually ready for it. The next best practice that you should talk about is, and I've mentioned it over and over again, really having a continuous integration and a continuous delivery story or system is a must. Everything that you have that is code, whether that's application, that's infrastructure, that's documentation, should be in a repository. You should be able to bring up your environments at the snap of your fingers and replicate environments very easily. If you start with continuous delivery and have this gated promotion type of thing, then you can make sure that you can build up to that last stage of having continuous deployment. As you guys well know, the term Rome wasn't built overnight, and so this is the perfect way to say that, but it really was not. And so we don't expect for you guys to immediately jump in and have a continuous deployment story. But what we hope you will do is start down the path of having continuous integration and deployment. So I've talked about, all these big terms. Let's get into the nitty-gritty of what AWS offers for you there. So in our DevOps portfolio, we have some tools that enable you to release and process. And they talked about some of those in your previous talks. But what I want to focus on here is that first bucket you see, the CodeStar, the code commit, code build, code deploy, and code pipeline. This is what is going to enable your continuous integration and your continuous delivery service. So let's talk about that. So where this fits in that 5 stage, or those 5 phases that I talked about, your source will be in code commit. We also support integration from Git. So if you are a GitHub person, we also support integration from coming in from Git. But again, from an AWS perspective, we have code commit. We have code build for your build environments. For tests, you can use code build and also third-party environments. We have integrated with that. And then for deployment, we have a system called code deploy. When you're talking about monitoring, because that was the last phase I talked about, you guys are probably familiar with CodeWatch, but how many of you guys out there are familiar with X-Ray? No hands went up. None. Anyone? No one. That's not good. Okay, well, I'll talk about that in a minute. But for deployment, you obviously have CloudWatch, but we also have released a new service, not completely new, but we released a new service that is X-Ray. When you look at those all together, to get into the continuous delivery, that's where your code pipeline comes in. It is the orchestrator of all these different services. Now, what I'm going to demo today will be how do I put these together if I'm just starting. And so we released a service called AWS CodeStar. And if you watch or read the AWS blogs, the main blog with Jeff Barr, you've probably seen me write articles on there as well, blogs about it. And one of the launches that I wrote about that I was really excited about was AWS CodeStar, because it brings all of these environments together now to allow me to quickly bring this environment up, and I can still customize it with these tools. So you have the option to build them each one as you want. If you're already savvy about your CI/CD environments, you can build each one of these separately. If you're just getting started, CodeStar is a great service for you that would orchestrate all of this once you give them your application. I'll show that in a second. So there are two types of continuous delivery that you think about. One, if you're into Docker containers, we have a code delivery type of pipeline, if you will, for containers. And that includes your source code, and this, again, can come from code commit or Git. You can set up your code pipeline. Again, this is some of the tools that we're talking about. Then you would go either use your build tool, you can use code build, or you can use Jenkins. So we do integrate with some of the systems that you guys are already using. And then you can deploy either building and deploying using the Amazon ECR, so I wanted to at least stick that out there. And then from ECR, then you can go to ECS. So again, if you're looking for continuous delivery for containers, this is kind of the system that works. Let me go back because I saw some of you guys taking pictures, so I went too fast. I can wait. All right, no worries. Now, continuous for serverless applications, very similar, but a little bit different. So I can start with CodeStar. By the way, you can also start with CodeStar for containers, but you have to do some nuances yourself. So if you think about it, CodeStar is just a huge CloudFormation template that we built yourself. So you can start there and then massage some things, but out of the box for serverless, you can start with CodeStar. Now, CodeStar will create a code pipeline for me. I can author my Lambda functions and my other things that I want, my Lambda functions, my API gateway code, my Swagger and everything else. I can use code Cloud9 and author those things. And then I could take that and then do a code commit using the source repository. Again, like I said, we support Git. I can go directly to code build, have all these things built. And this is including if you're using Java or Spring, it can compile that environment on your UI as well as your Lambda function. I can then publish that, again, using code build, and then I can deploy it. Now, here's the great thing about this when you're deploying with Lambda. That means I'm actually having my full application running in Lambda. And this is whether you're using Java, .NET, or Node. I can actually have my web server running serverlessly using Lambda. And all of the languages that we have support this type of environment where I can literally deploy and run on Lambda. What does that mean? That means I am not configuring any server to do this, and I can have fully robust, full-featured applications running completely serverlessly. And that does not matter whether or not you have your Express server as your web, or if you're an ASP.NET person, or if you're a Spring Boot person. It totally doesn't matter what your environment is. You can run your complete server on a serverless environment using Lambda. And so obviously we have the monitoring there with CloudWatch, but you also can monitor with X-Ray. And this means that I can monitor across a distributed system. So let me go into some of the details. I've been skirting around some of these services. I'll just quickly make sure you know what these services are, and then we'll do a demo. So code build, kind of obvious, but just to make sure you know that it is our fully managed build service. It also can integrate with third-party tools, and this code build is whether you're doing the serverless mantra that I just said, or whether you're using your Docker containers and have Docker images, I can deploy via that. We actually have some prepackaged Docker containers that are built. So if I say, hey, I want this to run on Linux or Windows, I can select that. And then I can go, OK, well, now that I've selected that, I want this to have this type of image. So you can use our prepackaged images, but what's great about it, if I've built a Docker image and I want that specific image to be my build, I can totally select that in code build by giving it the ARN. Remember for this, you can have this code build launched not only with Code Pipeline, but with Jenkins, like I talked about earlier. Code commit is your Git repository. If you need your own private, secure, Git managed environment, you can have all of your normal Git functionality, just like you would do with your Git on GitHub, or just like you would do if you tried to stand up a server and implement your own Git. We've done some of the heavy lifting for you with this. This is a normal Git repository. The trick is it's secure, it's scalable. You can really get granular with the permissions. So you use standard Git tools with this. And again, it's built upon the durability of S3. I skipped something that I'm going to go back out just to make sure. You have post hooks to SNS and Lambda. And this, I'll say, is really cool because one of the things I've done as I go around and I talk to you guys and I build systems with you is, what if I want any time that I make a commit, if I'm building my own type of environment, and some people they don't have all of these pieces in place. What if I want something to trigger the minute I make a Git, and I want Lambda to build a test environment, and I have different test environments I want to try out? I can absolutely have some post-commit hooks where I can dynamically build these test environments that I want to see runs best. So I just wanted to call that out. The third tool that I want to talk about, and I've been skirting around, but just make sure you understand what these individual tools do, is code deploy. And then remember, like I said, these deployments can happen whether you're doing it on ECS in your Docker containers or whether you're doing serverlessly. Another thing to call out here about code deploy is you can roll back if you have a failure. And most times when you're building your own deployment system, you're kind of building a bunch of things to, what do I do when it fails, and how do I roll this back? And the great thing about code deploy is we actually thought about that and had you in mind. Actually, we had ourselves in mind. What happens and what do we want to do when we detect a failure that we want to roll back from? So the great thing about code deploy is it actually has that functionality in it, and you can determine, what do I want to do? I want to roll this back. Maybe I want to roll it back to this type of build and go forward from there. So that's a part of code build. And again, I keep reinventing the wheel by saying this over and over again, but I'm going to say it one more time. You can deploy to EC2, you can deploy to Lambda, but what we don't talk about, and I want to make sure you know about code deploy, is you can also deploy to your on-premise servers. You absolutely do not have to deploy to just an AWS environment. Code Pipeline, then, is the stitching for all of this. So it will set it up where the minute I get something committed to code commit, it can kick off a build. Once that build is complete and have all the checks and balances, and by the way, not only when I say that build is complete, once all the tests have passed, then I can have it go to code deploy, and that can either deploy to a staging or beta or production environment, and then I can trigger how that will work when I'm finally ready to go to deployment. And then CodeStar. Again, if you're ready to get started really quickly, this is where CodeStar helps you. The final service that we released just in this past reInvent is Cloud9. And Cloud9 is baked into, you see the Lambda environment, but also you can author your different things in Cloud9 without being in a Lambda environment. So this is a managed service, a cloud IDE. It has a lot of collaborative things, so you can collaborate and code in tandem. So if you're into pairing programming, this is a great tool for that. And this is something that allows you to write and run and debug right in your browser. Now, I said I was going to talk about X-Ray, so really quickly, because I want to get to this demo and also give time for you to hear the customer story on this, is what's great about X-Ray is it's not just looking at your environment that's in AWS. What I want to do is have X-Ray really examine the calls that are coming into my environment. So let's say I'm using a third-party API, and I want to understand that I got a 200 from that, or did I get a 400 for that? And I want to make some decision points about what happened when that call came in. And so what's great about X-Ray is it can analyze your environment, not just on the cloud, but on-premise, and even if your environment is a hybrid one. So maybe some of your solutions run on-premise, some of the part of your solutions run on the cloud, some of your solutions depend on third party. it actually can visualize both in graphs as well as just not the text that comes across. It can visualize where your spikes are. It can identify for you where your bottlenecks, whether that's coming from the on-premise environment, whether this is a third-party call, and where you need to make optimizations. And again, this is across a distributed system. This is not just in your AWS environment. And so this is something that's really unique. If you think about how we build distributed systems, it's not in a box. And X-Ray can actually monitor across all of those, which I think is really fantastic. And it's available in any language that you so desire, and pretty simplistic to use. So your X-Ray can not only say, oh, I'm going to be put in the code and say, let's trigger and start monitoring as my code runs, but it also can be put in things like I can click a button and have the X-Ray service also examine my Lambda function. So I can examine the code that's running on the UI. I can examine the backend service I wrote. I can examine the Lambda function I wrote and see these spikes of how the calls went out and what came back from it. So this is something, if you haven't looked at X-Ray and you're thinking about building large distributed applications at scale, this is a way to monitor across all of those, and not, like I said, not just within your AWS environment. All right, so really quickly, let me just go to a demo. All right, so let's go to the browser. So what I'm in right now is in CodeStar. And as you can see, I do a lot of things with CodeStar. I've even had people that usually don't use AWS that want me to demo CodeStar. So it's a great service to get started if you have not built your CI/CD pipeline. So the first thing I did was just click New Project, nothing huge there. I have then ability to select where do I want to go. Do I want to do a Java Spring? Do I want to do Node? Do I want to do .NET, et cetera, et cetera? Do I want to run it serverlessly, or do I want it run in a container? So I'm just going to click Node here just quickly. And then I'm in Milan, so Milan, Terra, demo. And then it will create my project ID. I can determine at this point, do I want to use GitHub or code commit? I'll just keep it as code commit. I'll hit next here. Now at this point, it's going to tell me what my project environment is going to be. This is what the pipeline is going to create for me. So the pipeline is going to create one where it's going to look at code commit for my source, as you guys can see. It is going to build and test with code build, and then it's going to deploy using CloudFormation templates, and then I have my monitoring code watch. So this is what CodeStar is going to build my entire CI/CD pipeline for me. You need to click this button to say, hey, it's okay for CodeStar actually to provision these AWS resources on your behalf, and it will do that for you. So I'm going to create project. Now, while this is thinking, the trick that next is what's great about this is you now get to pick what your development environment is going to be. It doesn't just have to be Cloud9. So as you can see here, I can code in the command line, I can use Eclipse, or I can use Visual Studio. And what's great is I can do this at any time. And since I am, going to go at Cloud9, I'll just click Cloud9. By the way, you can switch tools at any time. Really easy to do. So when it asks me, do I want to set up my Cloud9 environment, I can say, hey, I want to just do this in a T2 micro. I have a relatively small development team, so I don't need a huge environment to be revisioned for me. I can actually do network settings here as well, give my environment a name, do some cost savings. I'll just drop these down so you guys can see it here. So I can actually give my different environments a name. Here, I'm going to let it pick the default name that CodeStar will also do for you. I can say that for a cost savings perspective, with Cloud9, I want my environment to shut down after 30 minutes, and I have some other options here after a day, after an hour, and then I can have it start back up at another time. I'm going to click Next, and you'll see at this point, CodeStar is going to go out, and it's going to set up my project. It is then going to build my IDE, and at that point, I will have a fully functional application running that I can start from. And you'll see it's already ready, and it says, welcome to Terra demo here. And if I scroll down, I can see my cloud environments with Cloud9 and start coding there. But it also, as it goes through, you'll see that I have a source that is now starting to build. This is the default source. if I want to actually see the code build environment that gets built from this, you'll see that when I click, I'm also in AWS Code Commit. So you could have already done this yourself. You could have done these things separately. But if you're just getting started with a CI/CD pipeline, especially if you're serverless, but again, we support containers in there as well, I can already have my AWS commit set up for me. And if you keep going down the like, if I select code build, you'll see that it created my code build environment for me as well. And it is the part the build will be executed as a source. Code pipeline will be the one that commits it. So I'm going to go back to the slides while this continues to build. And I am going to let that build, and I'll show you it at the end. But I want to let Andrea come up, and he will talk about what they've done with this at his company. Andrea?
Grazie a tutti, grazie all'AWS come al solito per ospitarci, invitarci a questi eventi. Ormai è il terzo anno per Docebo, partecipare indirettamente o direttamente all'AWS Summit Milano è sempre un gran piacere, sempre un grande onore. Quindi io sono Andrea, lavoro in Docebo. Cos'è Docebo? Ok, funziona. Docebo è un learning platform, è il nostro prodotto, siamo noi, la nostra azienda. Quindi una learning platform per portare i partner, impiegati, clienti di una certa entità a aumentare le proprie performance, le proprie conoscenze, la propria formazione. È quello che tuttora viene definito un LMS. Noi ci piace dire che una volta Docebo era un LMS, adesso è una learning platform, in quanto abbiamo lavorato moltissimo per uscire un po' dal paradigma del, tra virgolette, semplice LMS. Docebo in questo momento conta 5 uffici sparsi un po' per il mondo, come potete vedere dalla slide. Siamo ad oggi più di 200 dipendenti e abbiamo circa 1350 clienti paganti sparsi un po' in tutto il mondo. Al momento gli uffici operativi sono Milano, l'ufficio storico, la centrale operativa, Athens in Atlanta e Canada con Toronto per quanto riguarda il Nord America. Non sento più il ritorno della mia voce, quindi dovrò urlare un po' di più. Ok. Sempre in Europa abbiamo recentemente aperto Londra, abbiamo un ufficio in Dubai e in previsione per il 2019-2020 ci sono un ufficio in Germania e un ufficio in Hong Kong/Singapore. Un minimo di spaccato su quello che sono i nostri clienti. Tendenzialmente le top industries dei nostri clienti fanno parte del mondo di internet, la tecnologia, servizi finanziari, manifatturiera, c'è un po' di tutto, farmaceutica, un po' di tutto. 84% dei nostri clienti sono mid to large enterprises, quindi quelli che noi chiamiamo i piani appunto enterprise da più di 500 utenti attivi all'interno della piattaforma, mentre il 16% rimanente sono aziende più piccole, quindi con piani sotto i 500 utenti attivi in un learning plan di uno dei nostri clienti. Abbiamo anche alcuni case, alcuni dei nostri clienti, Uber poi è uno dei più recenti tra i grossi nomi. Andiamo un attimo all'infrastruttura. Docebo in questo momento su AWS, un po' mi sono accorto facendo le slide, rispecchiamo un po' quelli che sono gli uffici abbiamo operativi. Siamo live in questo momento su 5 region, le 2 region europee, quindi Irlanda e Francoforte, America per quanto riguarda Virginia, Canada e Australia. Quindi a parte Australia siamo abbastanza in linea con quelli che sono i nostri uffici operativi, con un'infrastruttura che da 2 anni a questa parte si è spostata verso un'architettura di tipo microservice. Oggi se ne è parlato tanto durante i vari speech, se ne parlerà ancora, e questo è uno spaccato molto di alto livello di com'è l'architettura Docebo oggi. Da sinistra verso destra, molto brevemente, un network load balancer su un autoscaling group composto da dei reverse proxy che fanno da terminatori SSL, fanno un minimo di routing tra quello che sono i servizi di back-end, come li chiamiamo, e l'applicazione Docebo, che è una single page application sviluppata in Angular 2 e ostata completamente su S3 come file statici. La parte invece, come dicevamo, di back-end è fronteggiata da un application load balancer che inoltra le varie richieste su un cluster ECS, quindi un cluster sviluppato con Amazon ECS e deployato su Amazon ECS, quindi composto da container, e ogni microservice è una piccola applicazione basata su stack LAMP, quindi Apache PHP, totalmente API REST, risponde totalmente a API REST. Sulla destra della slide ci sono uno spaccato un po' più esteso di quello che sono tutti i servizi AWS, o la maggior parte dei servizi AWS che utilizziamo, che era un po' complicato poi andare a condensare in un disegno, quindi appunto abbiamo parlato di ECS, Application Load Balancer, S3 per lo storage dei contenuti didattici e della single page application, RDS, Elastic Cache. Degni di nota, Elastic Transcoder e CloudFront danno un po' un'idea di quello che è anche la dimensione e la quantità di contenuti che noi eroghiamo. Solo nel mese di febbraio abbiamo conteggiato 450.000 minuti di video transcodati tramite Elastic Transcoder e poi erogati dalla nostra piattaforma, e un'erogazione via CloudFront, sempre solo per il mese di febbraio 2018, di circa 137 terabyte in un solo mese di febbraio. Vado a riprendere lo speech di Tera con quello che adesso è in fase, diciamo, ancora un po' embrionale da parte nostra, ma l'utilizzo dei servizi relativi alla alla continuous integration, continuous delivery messi a disposizione da AWS all'interno della nostra piattaforma. Noi abbiamo tutto il nostro codice allo stato su un'istanza self-hosted per motivi storici di GitLab, a cui abbiamo affiancato una code pipeline appunto sviluppata con una AWS Code Pipeline. Si parte quindi da una prima azione di sync tra l'istanza self-hosted di GitLab e code commit, perché usare due Git è un po' ridondante, me ne rendo conto. È un po' complicato migrare una sessantina, settantina di sviluppatori che lavorano ormai da 4-5 anni, hanno il loro account e quant'altro su GitLab, migrarlo su code commit non è proprio una cosa da 2 minuti. E mi piace avere il code commit come sorta di backup gestito da Amazon, completamente sicuro, completamente affidabile di quello che è la mia repository Git. Quindi questo è il motivo per cui c'è questa sorta di ridondanza sul lato repository. Successivamente, quando viene fatto il sync su code commit, tramite CloudWatch Events viene triggerato lo start della pipeline, quindi code build parte e tira giù il codice dalla repository Git e fa la build. In questo caso stiamo parlando della build di l'ultimo nato tra i microservice Docebo, che è chiamato internamente Loki, con molto affetto, e è un servizio basato su Node.js. Quindi nella parte di build viene fatto proprio la build dell'applicazione Node.js e l'installazione delle dipendenze. Il risultato di questo è un'immagine Docker che viene pushata su ECR, quindi il container registry gestito da AWS, e direttamente da Code Pipeline viene fatto il deploy su Amazon ECS. Quindi viene aggiornata la task definition con la nuova immagine e viene deployato il servizio con l'immagine nuova. Quali sono i benefici di questo approccio utilizzando i tool AWS? Innanzitutto, zero maintenance. Non dobbiamo mantenere il mio team, il team DevOps, il team di operations in generale, non deve mantenere, dobbiamo ancora mantenere il GitLab self-hosted, ma non dobbiamo mantenere tutto quello che vi è attorno, quindi la parte di code build, il deploy, è tutta roba che non dobbiamo mantenere, non dobbiamo patchare, non dobbiamo stare dietro se app, se è sufficientemente performante, zero. Scalabilità si collega quanto prima. Io in questo momento ho 12 microservice deployati, domani arriviamo a 15-20 microservice deployati. Per non attendere tempi eccessivamente lunghi per il deploy, in una situazione con un GitLab self-hosted dovrei aggiungere nuovi runner, dovrei fare in modo che questi runner funzionino in parallelo, dovrei occuparmi del fatto che i runner siano correttamente dimensionati e dovrei mantenere questi runner. Con i servizi, in particolare Code Build, non devo fare nulla di tutto questo. Aggiungo uno step alla mia pipeline, aggiungo un progetto di Code Build che può essere lo stesso, riutilizzare un progetto già esistente o farne un nuovo. La scalabilità è qualcosa di cui mi devo completamente dimenticare. Security Compliance. Code commit non è un server, code build non è un server a cui io devo fare accesso, devo monitorare accesso da parte di altri del mio team o di sviluppatori o di quant'altro. Sono servizi completamente gestiti in cui noi non abbiamo nessun tipo di visibilità e necessità di avere visibilità a quello che è l'accesso della macchina. Quindi a livello security compliance se ne parla tantissimo in questi giorni, GDPR e quant'altro, siamo totalmente a posto. Simplicity. I servizi, questa è una frase che mi sono inventato, sono più facili da utilizzare e da imparare rispetto ai software. GitLab è un software, come tale deve evolvere. Evolvere a volte vuol dire anche aggiungere funzionalità, aggiungere complessità. AWS Code Commit, AWS Code Build, Code Pipeline sono molto verticali su quello che fanno. Probabilmente rispetto a un software fanno meno, se vogliamo fare un paragone uno a uno, però sono più semplici di conseguenza da imparare, sono più diretti, sono più chiari e anch'io dovendo magari spiegare o introdurre nuovi dipendenti, nuovi collaboratori nel mio team, c'è meno da dover spiegare, da dover tramandare. Cost saving, tendenzialmente mantenere un'istanza GitLab, quindi un'istanza EC2 grossa, quanto serve, sempre accesa per fare i push, la parte repository o per fare la parte di continuous integration, costa mediamente di più che quelli che sono i costi di code commit che vanno semplicemente a utente registrato e attivo su code commit, e i costi di code build che sono limitati alla durata della build stessa. Quindi è tutto molto più economico rispetto a mantenere un'istanza in casa. Cosa importante che si collega sempre al discorso di Tara, molto brevemente, il monitoring. Noi utilizziamo recentemente un software che si chiama Dynatrace, si basa sull'installazione di un agent, un singolo agent, indipendentemente da quali sono le tecnologie in cui noi sviluppiamo, che va installato sull'host dove gira la nostra applicazione. E questo agent è fortemente integrato innanzitutto con AWS, tramite CloudWatch e tramite integrazioni in generale con le API Amazon e in particolare il tagging delle istanze dei servizi su Amazon. E poi è integrato con Docker. Questo cosa ci permette? Questo è un servizio, appunto, Loki, il servizio di prima, Node.js. Se notate, c'è l'over, la nuvoletta, mi fa vedere l'istanza, o meglio, l'immagine Docker running in quel momento per quel servizio. Dal tagging dell'immagine io vedo la data e l'hash del commit della build. Quindi io sono in grado di capire se il mio servizio diventa scarsamente performante o ci sono degli errori, so che è dovuto alla deploy a quella determinata versione del mio software. Quindi sono in grado di intervenire e eventualmente fare un fallback. In futuro andremo a estendere l'utilizzo di questi servizi messi a disposizione da Amazon con il resto dei nostri microservice. Loki è il nuovo arrivato, è stato sviluppato già in quest'ottica. I servizi un po' più legacy richiederanno un pochino più di lavoro. Un'altra sfida importante sarà quella di andare a gestire questo tipo di deployment in multi-region, appunto, come vi raccontavo prima, sono 5 region. Non è facile, non è neanche tanto facile o pensabile dire facciamo una pipeline per region, un repository per region, diventa complicato, e inserire all'interno della continuous integration e deployment le migration database. Grazie a tutti.
So we are out of time, but I want to make sure that if you guys, just so you could see really quickly, what happened after I let that system build. Very simply, very quickly, once that's loaded and that was finished with CodeStar, I actually, like I said, have a working application that I can execute on here, that I can start and use as an application, that I can start to have my applications built and to use this as a platform. So this code is in code commit. If I swap it out, it would actually trigger the pipeline build that you saw that he talked about they use. This is one view of it in CodeStar, again, with each phase. This is your entire pipeline, and then you could also look at your code details. So we want to really thank you guys for listening today. Thank you for looking at this. If you want any more details, I'll be at the AWS Genius Bar over there. And if you have any questions that, hey, you're burning to ask me, you can also tweet me at @TARAW. I actually answer those, and I'm definitely open to hear your questions. Have a great one. Thank you, guys.